How do we find out when it's actually on?
We're live.
Oh,
Hi, everyone.
oh, good. Can people type in the comments so we can see that you can actually? I don't know. I always look for verification that it's working. I don't know how many times I've started to record something and it's like, oh, there it wasn't recording anything. So, well, all right. Hopefully, people will start typing in the comments here soon. Anyway, we're going to talk about the PTJ this year. So a couple of different things. One is that this is I think our 6th PTJ, and the one from 2 years ago, we made the low-tech laboratory movie from what happened there. And I think that the movie turned out pretty good. It was pretty cool. And then last year we did it, and we made we said we'll make the low-tech laboratory movie 2 from that. And so we had a lot of fun projects and got a lot of video. Andreas told me yesterday that movie will be all done tomorrow. I'm not holding him to it, but it could be 3 or 4 days out now instead of, because it's been a while. But part of it was that some of the stuff that we did this year, we were kind of wrapping up some of the video from last year. And so Andreas wanted to get, and it finally got to the point where it was like that constant thing. In fact, even for this event where there's a bunch of us all here talking about this, it's like every time we tried to pick a date to record this, somebody couldn't make it. And so today Mike's not going to be here, but it's like we finally, just decided we got to do something. And so here we are. But
miss you, Mike.
There was similar stuff for some of the, like, okay, we need to record something where we talk about for the movie. And then somebody said, oh, well, we'll just record that at this year's PTJ, because it had been postponed so many times to record the last little bit. And so it's like, just screw it. We're just gonna why should we record people talking about a thing from last year when they can sit in front of it and we can video them actually talking about it? So there's a bit of that. I think that there were some new projects this year, and I like the idea that over the next few months we might finish some of those projects up, and who knows, maybe someday they'll go into a movie or something like that. But finally, we're doing this. We're doing a recap. In fact, I wanted to do a recap during the skip event, but stuff just kept happening. And plus, people at the skip event wanted to talk about skip event stuff and not about the PTJ so much. So I've got a list here of like what looks like maybe 18 different things, different projects to talk about today. So at the top is Roundwood Pavilion. Then there was a ladder rack for Roy. Ooh, look at so Andreas is showing us the imagery of some of the stuff from the Roundwood Pavilion. So we've got that big. Anyway, we're going to talk in detail about each of these here in just a moment. But we did the ladder rack for Roy. We did Mycelium insulation blocks, the sepulcher root cellar, humus well. I'm not sure this isn't exactly a PTJ thing, but it came up during the event. We needed to repair a washing machine, and so fortunately we had a couple of experts on that who helped us to repair it, and so got that repaired. And there are also some electrical systems that just turn themselves off And so fortunately we got those restored. But that's not exactly a PTJ thing. But in fact, I'd like to get some feedback from people. It's being suggested that we should make a video, like a movie and a Kickstarter for some general repairs. I don't know if anybody, agrees with that or believes that that would be of value. I'm kind of thinking like there's got to be like a million videos like that already on YouTube. The thing I was told is like, yeah, but you don't know who to trust. And so I don't know. It's a debatable thing. The round door project, 7 foot in diameter, round door. The rocket mass heater in the red cabin got a big upgrade. And I kind of feel like that could be an entire podcast on its own. The rocket oven got started, and I feel like we need to take the bones of it out up to the boneyard until we're ready to return to it. Weird materials were that yeah, that we'll get to that. Rocket hot tub, the Bob lines plus the new Bob Ra line. I think that a thing that could be worth talking about for a moment is heat protocol. The yoga yurt with the cob floor. Rug repair, window quilts, willow feeders. A lot of stuff was done with willow feeders. And the last item on my list is Stephen's poo with a view. Okay, now that's just the list of all the things that I have written down to talk about, but I don't know. Did I leave anything out? What else do we need to cover? Did anything pop in your guys' heads as I was reading that list off? Nope.
Did you mention the humus well? I'm sorry.
I did.
It was on the list. I had a little audio edit. Thanks.
Number 5 was humus well.
The pump house. We did a lot of work up at the pump house too.
Oh, good one. Good one. All right. I have it written down now. Any others? How about if we start talking about the pump house since, we didn't have it on our proper list? So, Bo, what happened at the pump house this year? Okay, I don't hear any sound from you. All right. I still don't hear anything. So I do know that.
How about now?
Okay, now I can hear you.
Okay, I have to be on here twice for you to hear me for some reason. There we go.
Is that an Apple product?
No, it's 2 Apple products. Yeah.
Oh, I see. Okay.
Yeah.
Okay.
That's fair.
That's how you get Apple to work, is you have to have 2 of them. I just have 1 Linux product.
Yeah, 1 Linux equals 2 Apple. I've found that to be true. No argument there. So the scope of the project at the well pump house at the lab. So for anyone who is new to this thing, this was put in a couple years ago. It's a roundwood. It's a underground roundwood retaining structure that's earthen insulated around the walls. It goes down about 8 feet at the tallest part, 6.5 feet at the lowest part. And it is the structure that holds the well pump for all the water up at the lab. So when we got there this year for the PTJ, it didn't have any earth backfilled around most of the sidewalls. So Elliot helped me do a bunch of tractor work to get as far as he could, getting all the earth tucked up and getting the plastic membrane to keep that earth dry so it would be insulative. So we did that. We had to do a lot of manual earth moving in the back so that we didn't crush any of the squishy bits with the tractor. And then what you're looking at right now, we dropped a couple of large, several 100-pound boulders down into the bottom. And those will have, when it drops below 40 degrees, those will have an incandescent light bulb shine on those rocks and soak up that heat, so that when it gets quite cold, those rocks will be able to slowly release that heat and regulate that temperature. So that was the scope of that project this year. Yeah, I guess right now we're looking at clips from last year's movie where we actually insulated the roof of the well pump house structure with mycelium insulation. So we had the chance to check on that mycelium. It dried really well. I think there's still a lot of air infiltration. So another project that's in the works is to create a bit of a drop ceiling that won't be insulative, but will attempt to slow airflow out of the top and slow the egress of whatever heat is in the chamber. So lots of miscellaneous micro projects to get that well pump house to make it through this winter without having to shut off the water at the lab.
Right. I think, so most uh, well houses, at least here in Montana, they're like an 8-foot tall cement thing. There's this kind of cement container that's dropped into the ground, and basically it's reburied, and then it has like a little metal lid on top of it, but it's buried deep enough that it won't ever freeze. And all of the plumbing is at the bottom of this big hole. And so, but here at the lab, we were digging into bedrock right there. And so we couldn't get very deep. And so instead, what we did is we kind of did like the walls a little bit Wafati style, not entirely, but a little bit. And then and an insulated roof instead of a non-insulated roof, which is fairly common. So the whole thing is probably about, I'm going to guess 4.5 feet deep. Does that sound about right, Bo?
It's deeper than that now, because the bermed walls come up. So you can stand at full height on the inside with the roof closed.
Oh, wow. Oh, okay. So, all right. So that's got to be, 5.5, 6 feet deep.
It ranges from just under 6 foot to probably 7 feet.
Wow. Okay. All right.
Yeah.
So it's pretty deep. But the thing is that the Wafati style walls on the sides are going to be something so that they're going to be kept dry for the most part. And because they're dry, they have some slight insulative value, possibly more insulative value than the ones that are in the ground that have zero insulative value. So, and
so supposedly dry soil is R.4 per inch. Is that right, Paul?
yeah.
And wet
And then,
soil is 0 because water loves to transfer.
well, wet soil does have an insulative value. It's R 0.05 per inch.
Fair.
So,
fair.
so yeah, it's
not
it's
0.
very, yeah. So the dry stuff does have a slight insulative value. It's not terrific, but but it also is going to have a fair bit of thermal mass. But we did put a tracking thermometer down in there last year, and or during the winter, this last winter, and it was not doing well. But we didn't have like the sides done, and the roof was new. And I think when you got there, you were saying something about like the part where the roof met the box wasn't super great.
Yeah, there's like 1.5 inch gaps where the roof meets the sidewalls.
Yeah. So hopefully this year it'll do better. But so we've got plan A, which is that we have a little bit better insulation this going into this winter, and that seal between the roof and the walls is a little bit better. And then we've also installed a plan B, which is the giant rocks combined with the incandescent bulb. And so in case things get cold enough, the incandescent bulb will pop on, and it should be far more than what we need to keep that pump house warm. All right.
That's the hope.
Okay. What? Anything else about the pump house?
Well, there was the one time we saw it in the video of lowering the rock in where we had the roof propped up extra tall because it's quite secure when you just open it normally, but we had to make it taller to get enough clearance to get that bucket under there to drop the rocks. We had 2x4s, and you'll watch our friendly cameraman there beginning to lean against the 2x4. I didn't even see him, but our helper Mike was like, please stop leaning on the 2x4. So right at that moment, that is the moment where my head just barely did not get crushed by the roof. So yeah, that's the only other thing. There it is. There's the moment.
Because he knocked the 2x4 out.
He didn't knock it. He began to lean against it until we said, please stop leaning against the 2x4. And it took about 3 times of saying it before he registered that we were talking to him and that it was a potential OSHA infraction and deadly maneuver. So it's a pretty good moment.
I think it's important to embrace for all of us, everybody on this call, everybody observing this video right now, observing this, hearing it, if we do it into a podcast or whatever. But the thing is that it's really easy to point back in the history and say, everybody knows that the way that you do it is ba, 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 ba. And nobody would ever, and it's kind of like, you know what? It happens all the time. And it's like the most hilarious parts are the people that say, nobody would ever, and that's the person who ends up doing it. That's the person.
Well, Paul, it's somewhat ironic because there were 3 of us working on putting those rocks in, and those rocks came from the humus well site as well. There was some sharing going on there, and we had it all worked out. Like, look, we've got this rock, and this is going to happen, and nobody's going to be underneath it, and these are the hand signals to use. Because, just to make it really clear. And so the 3 of us had it all figured out. And then a 4th person showed up and kind of missed the safety briefing, and we didn't pause and kind of restart. And I think that's how that happened. But otherwise, we successfully placed 2-3 large rocks, very heavy, inside a hole with some delicate equipment.
I would say it was way easier than we expected it to be. Would you agree, Elliot?
Yeah, I think in the end it was, because we took our time and we prepared, and we really emphasized safety. We weren't just tossing rocks in there and then worrying about it later. That would have been really easy.
So I guess I'm looking for a little positive feedback that what I'm saying is true, is that you can prepare and prepare and prepare and prepare, and then there's always
shit happens.
Boo-boos. And it's like whenever there's a boo-boo, it's as if 100% of the people who were there or heard about it or whatever point at the boo-boo and they say, what a dumb fuck. Nobody would ever do that. That's so ridiculous. And I kind of feel like, we all make boo-boos, and it's like, it's going to happen. It sucks. But I think the thing that's starting to really drive me crazy now is the people that say, only a fool would do that. And it's like, dude, you are tempting fate, you know? Um,
Well, and
anyway,
and Paul, the sort of accent on this one is somebody showed up, which was great. We're always happy to share. You know, people want to wander by, see what's going on. Great. Somebody wanted to film it. And because their awareness, I think, was looking at the phone and what they were recording, they did not have the other situational awareness. That is a general problem with filming, not this person necessarily. And, just in terms of our own tasks and roles, that's an oops. And I feel like that was really on me because I was on the tractor controlling this thing. I could see the other people and what they were doing as well. So, yeah, things happen, and we can always do better.
and I think that's kind of a big part of the event, as well as like all the rest of the stuff we do all year long is to build some experience. And building experience does include going through some boo-boos. We recently posted a video about using that tool, that tree tripping tool, sometimes called a tree jack, sometimes called the timber tool, and it's hilarious how so many people have dumb things to say, and I kind of feel like, and I like the tool because we have a lot of people here that have never tripped a tree before. And I just feel like for them, this tool makes the entire experience 20 times safer. It feels so much better to me. And I'm so glad that we use this tool. It's such a relief. Anyway, so yeah, comedy happened. Bo, I'm glad that you didn't get hurt. Um, and yet, whenever we try almost anything, there's chances are some. But I think, of course, triple emphasis on safety and trying to make it so that things don't go sideways. But we're doing so many unusual things, so many things that are so different that we're going to have to just jump in there and try to think through the safety on our own, and but there's always going to be a boo-boo. And I guess my big thing is that whoever points at the boo-boo and says something like everybody knows, that's the person with the finger, that person is doomed to have a major accident that day. So just my experience. So I think the thing to do is to just be supportive rather than shaming. That's what I'm trying to say. All right. Anybody got anything else to say about the pump house? Bo, anything more?
No, I think we covered it.
Okay. All right, cool. Next item on the list is the Roundwood Pavilion. So, this project went the full 2 weeks of the event, whereas the pump house, I think that was just a couple of days, wasn't it?
It was about 4 days.
4 days? Okay. All right. But this one went the whole time. And so as part of it, Mike, who led this, Mike Hosel, he had a really cool log peeling tool. And not only did it peel quickly and effectively, more so than any other tool we've ever tried here, but it would leave the bark in a giant piece. I don't know, you could theoretically use these giant pieces of bark for stuff later if you wanted. But the idea is that the wood gets put up and there's a roundwood timber framing thing that's put up. And then maybe next year we could put some roofy bits on it. And but this year we can go ahead and hang some of those floaty chairs off of it. and we've got a sunshade attached to it for now. And but there could be more sunshades and more expansion of this. I think it looks cool. I think on this particular space between these two buildings, when I first arrived on this property, the space between these two buildings was brutally ugly. And then Des came in and he made that rock patio kind of thing in between the two buildings. And then Alice came in and built that beautiful roundwood picnic table. And now this is going in. So this space
This is
turning
Des.
in.
Did the rock patio.
So I can barely see
Here's
him.
Des. He did the rock patio. I did the rock
So Des
patio.
has a big sign over his face that says live.
Oh, well, that's Des, the live face.
Okay. Guy. So Andreas, do you want to like put Bo and Des up on the? Oh, he's gone now. Yeah. Okay. Never mind.
Missed your chance.
So I kind of feel like between the rock patio, the log picnic table, and then this new roundwood pavilion stuff, it's looking really, really handsome there. And plus, I think that the style of roundwood joinery that was done, the timber framing joinery, was I would say a little bit more conventional. So like I think that Bo, what you did with that grape arbor last year was unconventional, because that kind of slide in dovetail kind of thing, which is going to be in the movie. I thought that was really cool. But I do think that like one of the cool things is that Andreas, can you put that video-ish, that little image clip back up, please? I think that little bit is pretty amazing, because in order to move those heavy logs up, he built that really tall tripod there. So we just snagged some really long poles and made a quick tripod so that we could lift those logs. I thought that was really brilliant, and that's all done by hand power. It's a block and tackle, I believe. So I don't know, for anybody on this call, do we have anybody on this call that spent much time with that project? Clay?
Yeah, I'm actually in the bottom corner there on the left in the black shirt, lifting that up. I spent a day and a half working on that, and it was pretty fun. I worked on creating some mortise and tenons for those posts, the verticals, and the crossbar there. And then yeah, what we did was we put this tripod up, which those three poles have a hole through the top of them, and we chained those three together. Um, it was used to put up the back first, the closest cross log in the image there. And then we kind of walked it around because the legs were on the camera side of that log. We needed to move it all the way to the front log. So we had to walk that around and then hook it up to this log that you're seeing being lifted there. And then we used the block and tackle to lift that in place. And then we had folks on the roofs to line it up and then pound it in place, which it went in fairly easily. So pretty fun.
Delightful project. I think it's looking great. There's a bunch of knee braces this is about, there's a lot more stuff that was done after what we see here. but this is just one piece that looks very, very nice. Now it has knee braces on it. It has logs connecting both the like the far away bit and the near bit. There's more to it that's been completed. I think it's a cool project. All right. Next one, ladder rack for Roy. Do we have anybody on this call that worked on the ladder rack for Roy? No. I mean,
I installed it.
Okay, and by installed, you mean?
I didn't do any of the fabrication because they, it came off of the old truck, and they cut it up, made it longer on the front, shorter in the back, painted it. But
all right, so the story goes like this. We had a pickup truck, and Katie had a relationship with this pickup truck called Ranger Doug, and I believe she said something like we have to keep this truck forever or something. I can't remember, but she's very, very tied to Ranger Doug, and Ranger Doug had this amazing ladder rack on top of this very cheap and old pickup truck. I mean, the ladder rack was probably worth 5 times more than the truck. And so what we did was we used the truck a lot to carry logs around, to move, to go up to the lab and grab a bunch of logs and then move them someplace, and usually, logs that you could easily pick up and put on top of the rack. Oh yeah, there's a fair load right there. But Ranger Doug became sad, and I think Ranger Doug has a cracked block. So it's like, I think Ranger Doug's all done. Oh no, what are we going to do? And fortunately, we got somebody who I refer to as the benefactor, who just reached out and bought us a brand new hybrid pickup truck, and which has been just amazing. And I don't know, evidence that we are all loved. I can't recall how. So this new pickup truck we have is called Roy. I don't have any memory of hearing about how Katie feels about Roy, but maybe she's got too much history with Doug or something. I'm not sure. But the thing that we decided to do was to take the ladder rack that was on Doug and modify it to be on Roy. And it's kind of like all of the dimensions were wrong. I think it needed to be made narrower and shorter to go over, like the bed on Roy is narrower and shorter dramatically, but we wanted the length on the top to be the same. And so then we needed to add something to give it the ability to hold the weight on the front that's hanging way over the cab. And so it needed to be completely rebuilt. So they cut and cut and cut and welded and welded and welded, and then they needed to put a fresh coat of paint on it. So yeah, it took the entire 2 weeks to remake that ladder rack. But boy, we've already gotten so much use out of, well, both Roy and the ladder rack. It's been profound. But I don't know, it seems like every year at the PTJ there's at least one welding project, and it seems like everybody wants to get in a few hours of welding experience, and it's usually the first time they've ever welded anything. And Jim Jukzak was in charge of this project, which is kind of too bad because I'd like to see Jim Jukzak be in charge of, like, 5 other projects instead. I didn't think it was going to take the full 2 weeks, but Jim wanted to make sure that everything about the ladder rack was rock solid, that all the welds were first class, and then of course and all the sizing was excellent and perfect, and everything about it was excellent. So he was there the whole time to make sure of all of that. And I don't know, he put in lots of time for that, and everybody who wanted to get a little welding experience did. And of course there was a lot of cutting experience too, because the whole thing had to be cut apart in order to be rebuilt and rewelded. Anybody got anything to say about the ladder rack for Roy? Okay, well then we go on to another Bo project, Mycelium insulation blocks. Bo?
Yeah, I'm here.
Okay, there you are.
Do
we have
yeah.
There's pictures.
So this was kind of a big project. The idea was we wanted to see if we could use the spent substrate from a mushroom farming operation. So this, they use a combination of oak chips, oak pellets, oak shavings, other deciduous wood products, sometimes straw. Sometimes conventionally they use soy or a similar nutritive ingredient. I think these guys use organic buffalo manure, which is kind of cool. And then some additives like gypsum to grow mushrooms on, culinary gourmet mushrooms. So we wanted to see if we could break up those materials after they harvest a couple rounds of mushrooms off of it, pack them into pre-made forms, in this case, kind of giant Lego shaped forms, give them a week to grow together in their new shape, and then break them out and see what kind of properties they have to build with. I think when optimized, so there were a few levels to this experiment. We had to make the forms, which we made out of reclaimed cedar. I think they were fence pickets. Clay, did you bring those cedar pieces?
Yeah, they're all, no, you're right. They're cedar fence pickets that were 2 feet or shorter.
They weren't reclaimed. They were kind of
Newish. Yeah.
Yeah. So we designed and made those boxes. That was a full 4 days job just to figure that out and assembly line those together. We did a lot of, basic carpentry education to get those assembled. And then part of the experiment was, mushroom farming typically uses a lot of plastic, which in an ideal world we could totally avoid. So we were trying to see what other materials could be used to line those forms with, so that the mycelium could grow back together and then also still release from the forms. So we tried 12 different options for lining the boxes, ranging from nothing, just raw wood, planed wood, and also rough wood. We tried, there were a number of things that I was pretty confident would just totally not work, but we tried them anyway because I'm wrong a lot. We tried just dirt and dust. We tried clay, like a clay slip. We did one with kind of a muslin-like material. We did a number of them because I knew plastic would be the most likely thing to work for a lot of reasons. One, mycelium doesn't grow into plastic. Two, plastic can be sterilized very easily with just a simple alcohol spray bottle. So we used reclaimed plastic as a compromise, a couple sources of reclaimed plastic. We used beeswax. We both heated it and applied it with a brush, and we made a little beeswax puck that we rubbed against the interior. That one was a wild card. I was like, I have no idea what beeswax and mycelium do together. I couldn't find any research on the subject. I was skeptical, but I was like, this may be the wild card that does it. I'm trying to think if we did any other experimental liners. Maybe it'll come to me. Of those 12 blocks, 12 experimental blocks, the plastic lined ones by far did the best. The beeswax ones didn't work at all. It was as if the beeswax wasn't there. Everything that had wood contact, the mycelium grew into the wood. And the clay was just very contaminated. So perhaps if we would have tried some pasteurizing of the clay slip before through heat, that would have been better. I still think there's probably too much wood exposure with the clay. So if I were to scale this project up, I'd probably manufacture some infinitely reusable silicone molds that would also reduce our need for these intricate wooden boxes. They could just be molded in the shape and be a standalone mold all out of silicone. But we learned a lot. We learned a lot about what mycelium doesn't like to grow inside of. We learned a little bit about kind of the species that we'd like to use and the time constraints. I think we would have had marginally more success if we'd have let them grow together for 3 weeks instead of 9 days, or less than 9 days instead of 1 week. The ones that were marginally successful that still came out of the forms in a vaguely Lego shape, but either had some sign of contamination or had some like chunks that came out in removing from the form. We went ahead and made a bit of a wall out of those blocks behind the bun warmer in the berm shed. And I don't know if anyone's been over there to see how those things have done just out in the open behind the bun warmer. I don't know if they've grown together or have begun to desiccate. My guess is they haven't just utterly crumbled, but I'm curious to see how those are doing.
There.
So we found a lot of what I expected to be points of failure but we found we zeroed in on the narrow pathway to scaling up and success here. The possible applications are really cool. I see a future where we have, mushroom farming is pretty wasteful. The best operations compost their spent mushroom substrate, which is great, great use of carbon, great soil builder. But I envision a world where, like, instead of doing that, we're growing mushrooms in these block forms or in panel forms, harvesting fruit off of them, and then with no added extra steps of labor, busting out the substrate already in its useful shape for insulation or building blocks. These kinds of blocks could be erected and then allowed to partially dry and then cobbed as you would a straw bale house, or potentially just plastered directly to the surface of the interior of the block and plastered and lime washed on the exterior, depending on your climate, which makes them just a value-added waste byproduct. To me, it's a no-brainer. If I'm going to farm mushrooms, I'm going to get extra value out of the mycelium. And if I'm going to grow mycelium for industrial applications, I'm going to get extra value out of a mushroom fruiting crop. So I could talk about this for another hour, but that's a good overview.
Any ideas on something we could try that's not plastic to be the liner in those forms?
Silicone.
Anything more natural, like we find lying around the ground? No. Sounds like a no.
Yeah, I mean metal. If we find, there's a lot more embedded energy in metal, but it's infinitely reusable and can be sterilized. So I could see potentially sheet metal.
What about like aluminum foil?
Yeah, I think aluminum foil will work.
Oh. Well, okay. One of the ideas that we've had is like, let's make a whole bunch of these blocks. And you've made the case of like, you don't necessarily need to do the Lego shape, because if you just kind of like put a little bit of water down as you're putting the blocks on top of each other, they'll kind of grow into each other and lock together anyway. So you don't need that Lego thing, that Lego factor.
Right.
And I think that is rather amazing. It's possible that we might want to make something smaller first. And I'm not sure what that might be. Like, we don't have a lot of need to build a doghouse or anything like that right now. But a wall somewhere, perhaps.
Maybe an interior partition wall in the bunkhouse, separating the solarium end from the bunk room. Just like even a little pony wall, not a full wall. Something with lots of exposure to watch how it coalesces.
Or maybe a bit of an exterior wall on one part of the berm shed.
I could see that. Yeah.
Yeah. And so I just kind of feel like the idea of ending up with, I don't know, 400 building blocks that have an insulative value that's better than fiberglass insulation, and they're structurally sound enough that you could mount a roof on top of them.
Yeah.
I don't know, just the mind boggles at how amazing this building material can be.
Yeah. The comments, I do think glass would work well. Of course, if it's a form, you have to have glass that you can disassemble, because it's going to be real tight. You couldn't do it like in an aquarium. It would not want to come out.
Yeah.
But glass is an interesting idea. I think one of the coolest developments this year, the main pinch point on getting this to really be a success at the PTJ is that it's only a 2-week event. Because mycelium takes a minimum, depending on species, of 6 to 10 weeks to inoculate the substrate. So we cheated by procuring already inoculated substrate from a local mushroom farm, and that's the only reason it's possible at all to even experiment at a 2-week event. The cool development was there's a mushroom farmer local to you, Paul, called Blood Veil, who's really keen to actually partner with us more extensively. They're open to the idea of growing a portion of their crop in forms that we would co-design, and setting them aside for a period of time so that we have purpose-grown stuff from them already. Because I think to scale up in this technology, you really need someone who's on site full time, who is both farming mushrooms and intentionally harvesting this insulative block or panel material, rather than just a 2-week period. So with a partnership with the local mushroom farm, that might be possible up near your place for the first time.
Okay. Neat.
Yeah.
But in theory, we could, let's say, make 40 forms. Like, let's say that the aluminum foil idea works out. Then we could make 40, we could get 40 of them going with aluminum. And then we could set them aside for, I don't think they even need a lid. I mean, they need the walls that are kind of pinned together. And so that way you have the ability to take the walls off. But I suppose that if you just stack them on top of each other and then ignore them for 2 months?
It depends on what you put in. If you're breaking up already spent blocks, you only need, 2 weeks. If you're putting in raw substrate, freshly inoculated, 2 months. If it's a whole integrated mushroom farming operation, you're on the 2-month scale. And that's just to harvest your mushrooms. Then you need to seal them back up so that it can recongeal That's the wrong word. Seal any wound points from the harvest.
Okay. So, the next thing is, oh, that does not look handsome.
It's a nice failure, isn't it? I love that. But look how well it grew to the wood. So, I mean, one other possibility, this is a great video to talk about this. So you could build wooden block forms where you actually construct the structure still in the wood, like a structural insulated panel. Because before I opened that box, what you had was a very high R value structural insulated form that's wood clad. So you could potentially open up the top and the bottom, but leave the sidewalls, and they could grow together at the points where the mycelium intersects, and you already have interior and exterior cladding in the wood.
Oh, so you're saying so basically whatever you build, it's kind of got this slight amount of wood involved in the structure as well.
Well, you're growing a structural insulated panel, which is like an ice cream sandwich with wood, insulated material, and wood. Only it doesn't use expanded polystyrene, and it doesn't use adhesives, and it doesn't have to use OSB. It's using natural cedar. So that's a really compelling possibility that we weren't even researching, but I really love that idea.
Okay. Another idea would be to make the frames out of like aluminum plate. So like if we had some, I'm going to make up a number of 1/8" aluminum, we could, that would be the actual box. And you take the box off, and then you're going to be left with this exposed mycelium block. And the place I was going a moment ago is like you could do 40, and then you do 40 more, and then you do 40 more until you have enough to build whatever it is you're going to be building. I mean, but it would be like you'd have to be thinking in advance. However, you would end up with something that's very well insulated.
Yeah. Yeah,
So,
to the comments point, part of the problem with the ones without any plastic lining was certainly moisture loss, wood being very porous, and other lining experiments that were more porous did lose moisture content. Some of them we wrapped the exterior of the box in plastic to try to seal some of the humidity in that internal environment. But the ones that were just straight up wood dried out too much, certainly.
okay. All right.
What I got a question about the R value. You said it was a high R value. What kind of R value do you have there?
When it's dry, it depends on the species and the substrate, but it's tested out to be between R 3.7 and R4 per inch. So slightly better than fiberglass and mineral wool.
Cool. Thanks.
Yeah.
Okay. The cool thing is structural blocks that are insulated. And I mean, what a great use of wood chips. Yeah. Like if there's a lot of sawmills. We have a fair bit of sawdust from our sawmill.
Right.
And so I'm kind of thinking like, oh, we could put that to use.
Yep.
Oh, there's a nice looking one.
Yeah, that one's okay. Now, Paul, have you been down into the classroom recently? Because the two best blocks were sitting right behind the double barrel for the rocket mass heater. And it used to be that that one of the boots was sending me pictures as one of those blocks was even fruiting. It had mushrooms growing out of it. But I haven't gotten an update in over a month. So I'm really curious how those two best performing blocks are looking now.
Oh, I was down there. I took a little bit of B-roll footage of the rocket mass heater in the classroom. I don't know, like 3 or 4 days ago, but I didn't attempt to go and look behind the double barrel.
Yeah.
Sorry.
That's okay.
So I don't know, but we've been cleaning up after the PTJ and the skip events. So things are looking really tidy in there now. But I didn't know that if I looked in just the right spot, I could see the progress of a project.
Yeah.
Okay.
Maybe I'll ping
Now I
Steve
know.
and have him take a peek when he gets a chance.
Okay. All right. We'll do. We'll do. All right. Anything else about the mycelium insulation blocks project?
Yeah, but I'm not going to take up any more.
Okay. That was
project. I'm excited to do more.
Yeah. That I feel like there's tons and tons and tons more to talk about. And I do want to build some stuff, but and Elliot, you're getting kind of dancy in your little what's
You're on mute, Elliot.
we can't hear you. This is kind of like Hollywood Squares.
Yeah, there we go. Sorry, I had a teenager enter the room and depart.
So sign
Notoriously
language.
loud.
Yeah, no, I was not waving at y'all.
Okay. All
Anyway.
right. Good. All is well.
Funny.
Hey, JR. Next up on the list is the Sepp Holzer root cellar. And so we're going to try to make a really big root cellar. And Sepp Holzer says that he can build it in 10 hours, provided, of course, that all the logs are there, an excavator is there. And I'm going to guess 6 people who really know what the fuck they're doing. You got that? And he says 10 hours. And I think what you and I have learned is that a Sepp Holzer hour might be longer than an hour for the rest of us.
Yeah, I'm thinking so. Actually, obviously so. But then again, he has people that have done it so many times that they know exactly what's going on, and you have different variables in there. And also, he doesn't detail it out that much in the book, so it's hard to tell exactly how they. And I think the holes dug, all the logs are there, peeled, and he's got an experienced crew.
Okay.
But it's a lot of work.
Doing it the first time is definitely going to take a lot longer to do than doing it the 12th time. And I'm going to guess that when he builds it the 12th time, or when, like, if you have your best 6 people and then you guys, get to your 12th time, I still think that whether it's Sepp Holzer's team or it's you and your best people on the 12th time, at the very shortest, 2 10-hour days. What do you think?
Yeah, I'd say so. Yeah.
Okay. So, yeah, and there you see somebody peeling a log, and it's kind of like, I think that Sepp's got the logs already all peeled and ready to go. But last year, you took a few days, like 6 days. Yeah, 6 days to kind of get the logs set up. And then on Tuesday morning of the second week, it's like, okay, here goes our 10 hours. And and it's like, okay, so then you used up all 4 of those days for last year, and then all 10 of the days this year, and it's kind of done-ish, but there's still some to be done to get to call it really done. And
yes.
Is it possible that you're going to come out here as a ringer for a week or 2?
It's possible.
Okay.
It's got to get done. It's got to get done.
Okay. I like the description that you had and the little drawing that Andreas had up there just a second ago, kind of showing, because that one right there. I feel like that is just a perfect drawing, and your description just perfectly matches that. And because Seb Holzer, he's dropping about $6,000 on the roofy bits, and I think that for us it's going to be closer to like I don't know, $400. Um, and at the same time, I think that ours is going to be better. So
I think so.
oh yeah, and but we haven't even gotten to that part yet. Ooh, cool. I see a note here. It's attached with $5, and it says, "So I got a 12-pack of your Better World book, and I'm gonna need to get another soon." Oh, sweet. So that's right. I remember people can put money in their comments on the YouTubes. All right. I want to apologize to you for having it take so long, because it seems like in the years past when you've been here working on stuff, you'd work on like a whole bunch of different projects and you'd just knock them out one after another. And it did seem like this is something that it's going to take 1 10-hour day at the beginning, and it just kind of goes on and on and on and on. Now, I have noticed that one of the things that you're doing that would make it take a lot longer is that you're pinning each log to the previous log. So each time you put a new vertical log in, you're pinning it to its neighbor.
Yeah, we had to do that because our trenches, we couldn't get a small enough bucket when we dug the trenches for the logs. So we weren't able to pack the gravel around the logs until we had a few ahead of it. Is that making sense?
It is making sense.
Yeah, so we had to do something to get the logs to stand upright and stay in place. So that's the reason we had to pin them. Yeah, every one of them.
So another possible thing that could have been done would have been to like make a kind of a log form, so that as the other logs are dropped in, it kind of holds the logs in place until the pinning logs at the top can be pinned on, and then the gravel can be poured in at the bottoms to kind of hold it all in place. That would have made it go a lot faster, perhaps.
You'd still have to do something to keep the top all in shape and keep it shape in that whole thing too.
Right. I mean, if you put a form in, that'll hold the vertical logs in place. So like you've got some kind of log-based form on the inside and a log-based form on the outside, and then each of the vertical logs kind of goes in and can be kind of, quickly wedged in place. And then you go and you cut down all the vertical logs at the top, so that way they're all level. And then you put the pinning logs in, and possibly even the roof logs. Then you can start putting the gravel in and pack the gravel in, and that might hold it all in place. So the thing I just described would probably go a lot faster than the pinning that you did. Would you agree with that?
It's possible. It's
maybe
it would have gone a lot faster if we would have just had a small enough bucket to just dig the trench.
That's a very good point too. And so maybe Seb's got that small enough bucket, and then he just drops all those logs in, and then he kind of shims him or something like that to hold him in place until enough of them are in that he could put the cap logs on the top.
Yeah.
So
Yeah.
maybe it's a bunch of little tricks like this that make it so that he can do it in, well, maybe not 10 hours, but maybe 2 10-hour days.
Yeah.
Okay. So, all right. But what's there is looking pretty cool, and it is rather massive.
Yes, it
Is
is.
it
Go ahead.
25 feet deep?
25 feet. Yeah. Sep usually does them 20 feet long, but because we couldn't get it facing true north, uh, totally, we didn't want any sun getting onto that front wall when we build the front wall. So we brought it out another 5 feet to kind of help shade that front wall and the door,
Right. Right.
so we don't get heat.
Okay.
But I didn't even realize until we got done with it this year, really how massive that thing is. It's huge.
It is huge. The nice thing is that when it's done, we could put a lot of shelves inside of it to hold a lot of food. And so, and this year, we're already starting to get quite a bit of food out of our food system. So it would be great to put inside of a root cellar. So therefore, I think next year we'll have much, much more food than we'll really need all that space. So, all right. So the general idea is to dig trenches where the vertical logs will go, preferably narrow trenches. And then you're going to drop a bunch of logs in those trenches. Then you're going to go and cut all those logs to a very exacting height. And so they're nice and level next to their neighbor.
Yes.
And then you're going to lay cap logs on top to kind of hold them all together. Then
Right.
you're going to put a bunch of roof logs across the top. That'll also help to hold things together in a different way. Then you're going to lay a layer of plastic around, on that. Like the plastic will be on the logs, on basically this log box that you've created. And now you can lay a bunch of dirt on that, and then the dirt that's on that can make a shape. There's the picture right there of the dirt that's on that, can make a shape so when we put plastic on top of that, it sheds water really well. Then we
Right.
put another layer of dirt on top of that defines the umbrella. And then we put a layer of plastic on that. So the plastic that we're putting down is a like 6 mil. So good chance each piece of plastic is going to have 1,000 little holes in it, which is fine. We don't care about the 1,000 little holes. Each layer of plastic is going to do a good job of shedding 98% of the water that touches it. And so if 2% of the water makes its way through to the next layer, then only 2% of that 2% makes it to the next layer. So I think we're going to keep it pretty damn dry.
Yeah.
On top of that, the all of the dirt on the outside of it all is going to make it so that you start to get your root cellar effect. This, by the way, is a north-facing slope. There's things that we could do on the downhill side to help try to pin cold air into the system later, but that would be more of a freezer wafati than a sepulcher style root cellar. But the shape of the plastic on the top is going to help to keep, help shed water in a variety of different directions, preferably to the sides, not to the back.
Correct. Yeah.
All right.
And when it's done, the earthworks around it, it'll divert the water that's uphill from it around it. And I've had a thought. I haven't got to talk to you about it yet, but I've had a thought. Okay, we put down one layer of plastic, the first layer of plastic around it, but they make these bentonite blankets, and I was thinking that'd be even more natural than the plastic. They use it, and they use them for like pond liners and
Yeah.
stuff. So why
I think
wouldn't
as a
that?
pond liner, it would be good, but for us, it would be a really terrible idea. And the
Well,
reason is bentonite, basically, once it absorbs water, it grows to be 9 times bigger.
okay,
And that's why you can seal a pond with bentonite.
okay,
But then the converse is that if you've got a bentonite blanket, then and it's dry, then the only time it'll shed water is when water touches it. And so by then, some of the water may have come through.
okay.
But I don't know. This is the first time I've ever heard the phrase bentonite blanket. But
Yeah,
I think regular clay, like just like the clay that we have naturally, that we can dig up on our site just a few feet away from where we put this in, that clay, I think, would probably do pretty good as an impermeable membrane. But I didn't want to do too many experiments with this. I wanted to keep it pretty simple. Plus, you know, if I introduce clay on a sepulcher structure, does that mean that if it fails, does sepulcher look like a dummy, or do I look like a dummy, or both of
yeah,
us? And so it's kind of like, let's, this has got enough experimenting going on. And plus, on top of that, I think it would take a lot longer to try to do a clay layer than to do 6 mil layer.
true, true. I'm just
And
thinking about putting the plastic in the ground is my only thought on that. I'm not really keen on putting plastic in the ground.
no, I'm
But
not keen on that either. And I'd like to find some better solutions. And I think that, there will be a day when we build a wafati that has no plastic. But that'll be a wonderful experiment. And I've got a lot of ideas in that space, but they're, well, experimental. Okay.
that's the thing about experiments. Sometimes they fail and then you learn.
Right, right. So there's a question about how to deal with termite and insect pressure. I think that the number one thing that we do is we freeze all the termites to death for the entire state of Montana. I don't know if there's any termites in Montana at all. There might be a few. I have no clue. I've never seen a termite in Montana. But there are other insects that love to eat woody bits. Most of them love to eat woody bits that are wet and rotten. It's not very common that you get things that want to eat the dry wood. So we do a lot of projects with dry, untreated wood, but we try to build a large eave to protect the wood, so that way it doesn't get water on it, therefore rot. And so I don't know. I have I have shelves that are 30 years old that have never been treated with anything, and they look almost brand new. So wood can last a really, really long time untreated in this area, provided that you just keep the water off of it.
Yeah.
JR, does that sound all right to you?
Oh yeah, that's very true. Very
Yeah.
true.
So, oh, and then here's Andreas showing showing my little video about posts in our structures and how we get them to last a long time. All right, JR, what do you got to say about the build itself?
It's been a whole lot of work, but it's been a lot of fun. It's been a learning curve for everybody. And I think it's well worth doing.
It seems like you attracted the biggest crew.
Thank
You had
God.
the most people helping you out.
Yeah, I've had some really good people helping me on this project. The last 2 years, I've had great people up there. I'd like to see them back again to help finish it up. But
Are there any of the details you want to talk about while we're, looking at it?
You know, yeah, I'm drawing a blank at the moment.
I could remind you of something, Katie here. JR.
Hey, Katie.
Sorry, just putting the logs, every other one with the top up and every other one with the bottom up.
Oh yeah. Okay.
That's really important when you're building a root cellar.
Yeah, that was something that we needed to make sure of on our taper, because none of these logs are going to be straight. I mean, they're going to have a taper to them, all of them. So as we were putting them in, we had to just to make sure everything stayed straight, we'd alternate the fat end up or the fat end down, just so we could keep the logs straight and we weren't all whoppah-jawed on the end, so we could come out even on the end. Because if you put them all in the same way, you'd have a leaning tower of pizza. It'd all be laying over by the time you got out to the end.
Right. They'd all be there'd be a lot of gaps at the top, if nothing else.
Yeah.
And then when you try to put in the plastic to hold it all up, then a big enough gap and the dirt that's pushing against it might push clear through.
Yeah. And that was another thing too. We were always we're wanting to twist it. Some of them were bowed because we didn't pick out the straightest trees, and that kind of thing. So we'd do the bow. We'd put the bow going towards the outside of the structure, because that way the dirt would help press it in and hold it in place a little better. We didn't want it bowing in. That would, in my mind, it'd weaken the structure, with all the dirt on top of it. So
I think that's smart.
That was one of the big things there too, was doing that. And then on the roof logs, we're doing saddle joints on about every 4. We were going to do a saddle joints on every one, but that takes a long time. So we decided we're going to do it on every 4 logs,
which is what SEP does.
Yeah. So that's what we're going to do on the roof logs, and we're using some of our biggest bowed logs for that, and the bow's going to go upward, so it'll have kind of an arch ceiling and help us to create create more of our mound for water shedding too. And we'll chamfer those edges of the logs, the roof logs, to kind of soften those corners for when we put the plastic on, so it won't be so apt to tear and things of that sort there.
Good. Great. All right. I think we're ready to go on to the next item. The next item on my list is repair washing machine. Is there anybody on this call that was involved in that project? And then there's electrics upgrades, same thing. I think that they're not exactly PTJ things, but they are things that kind of came up. And Jennifer, who ran point on both of those, is trying to convince me that we should, give them more weight. And so I'm thinking like, okay, that's something that, I'll try to send out a poll to people later, perhaps. What about the round door project? So that one went for 3 days, I think. And we have something that does look really beautiful. It is definitely round, and it's very wood. In fact, Sky Huddleston, who led that project, he presented me an idea. I thought it was going to need to be a 1/4 inch thick steel plate with wood clad to it, because if you're talking about a 6.5 foot diameter round door, and in the end, apparently they decided to go with a 7 foot diameter round door. But if you're talking about such a giant round door that's going to be 8 inches thick, I'm thinking you're going to end up with something that's about 800 pounds. And in order to be able to hold all that weight is going to require some engineering. And I thought it was going to be a 1/4 inch round steel plate with a bunch of wood clad to it, and all the insulation for the door and things like that. But Sky came up with the idea of, instead, let's get a bunch of 2x, and we will put all thread all the way through. And I think that the idea has merit. I think it won't be as strong as the steel plate idea, but I think it'll be close. Did anybody on this call put any time into working on that project? Nope. Okay.
I did a little bit, mostly on a consultant capacity. It feels like what they've done is the most, I don't know. I was using some cross-laminated timber ideology to kind of improve the structural integrity by having the wooden layers going in opposite directions so that the fibers would be in tension with one another. So yeah, but that's about it.
I do know that they had a lot of stuff about like rather than a layer where all of the wood ran diagonally, or a 90-degree angle to the wood that's there, that they wanted something that would fan out from the hinge. Was that your idea?
No, that wasn't.
Okay.
But I don't think it was a bad idea. I suggested diagonally against the point of tension where it hangs from the hinge. And they went with the fan, which I think is fine.
Okay. I just need to say the same thing I say every time we talk about the round door idea, is that 80% of the engineering is going to be in the wall that holds the door. And Sky, while Sky agrees with that, his position was, because I was imagining more steel plates in the wall in order to provide the structural integrity, to counterweight, to hold that door up, this very heavy door. And he had a lot of ideas about timber framing and how to get the timber framing to be able to hold it up. Oh, there you can kind of see the round door under construction. So I think I mean it's now been put away, and we will finish it another time. So that there's just as far as I know, there's just one layer done to the door, and that's the layer that has all the all thread to it.
Right.
So I think that I don't know. I'm excited about it, but I also kind of feel like, you know, this year, even if we were to have finished the door this year, we could finish the door and we could finish a bit of a frame for the door to rest in. But we still would need to do the engineering in the wall where the door is going to go. And we
Which is probably the lion's share of the thought work and engineering.
Right. And it's also not the sexy part. The sexy part is making the door.
Yeah.
And then it's like, look at this beautiful door that I made. And then when you do the hard part, which is the engineering in the wall, there's like no sexy points for that. It's like everybody's looking at the door. No one's thinking about the engineering in the wall. I mean, I'll give you sexy points. I think that that's the most sexy part, and that the door is easy compared to the rest of it. But I think most of the observers to the final product are going to be hyper focused on the door itself, on just the door, and they won't even think a moment about the engineering in the wall. Although Sky did bring with him the hinge, so he made the hinge at his house. And it is a glorious hinge.
But it needs something equally glorious to affix to within the wall.
That is true. That is so true.
It's a crazy hinge. It was scary. It was like floating around at meal times, making my fingers nervous. It's a very stout hinge.
It's got to weigh like 65 pounds or something, doesn't it?
Yeah, when people came in with flip-flops, I was like, watch out for the hinge. That is a very heavy chunk of metal.
Next item is the red cabin rocket mass heater upgrade. And so we just finished, we put up on YouTube a few days ago a video where Mud and I spent 2 hours talking about upgrading the rocket mass heater in the red cabin and the several different things that we wanted to do. And here in a couple of weeks, I think we're going to probably finish this and put the finishing cob layers on and things like that. The funny thing is that, we're doing this thing now called themed weeks, which is kind of like a step down from a workshop, but it's kind of like, come on out and rent a cabin here for a week or two and participate in, you know, some of the projects that we do all year long. And so a week from now, Harvest Week starts, and I think we've got like 7 or 8 people coming in for that. But for Rocket Week, so far we have 0 people coming in, and I thought that's the one that was going to fill up first. So we have a big project that Mud did is to put on not only a cob hat in there, because the rocket mass heater as is in the red cabin is working fine, but we just kind of had a whole lot of ideas about how to make it work extremely well. And so we decided to do these bits of project to get it to work extremely well. And the cob hat is one. Another thing is the cob cape, which includes going around the vertical exhaust in such a way that when you start the fire, the vertical exhaust will start to get warmed up. And so we're kind of hoping that this winter will do great. Now, right now, it's in there. It's in fairly rough condition. I don't know if we have a picture of it anywhere that Andreas can put up on the screen. Maybe not. I know that there have been some pictures that I've seen floating around, but it's got that weird texture that's put on the outside of cob so that the next layer can get good traction in it and hold on to it really well. So we do need to get some finishing layers on there. Oh, there's Mud. He's building the new cob hat. He made this decision to put a metal plate on the inside during the build of the cob hat. So cob hat always has a gap over the top of the barrel, and we chose the dimensions of the gap to be the same as a lasagna. Like you could put a lasagna in there if you wanted to. But I think it turned out looking rather odd, but I have great hopes that it's going to be just amazing at keeping that space very, very warm, while at the same time making it dodge the cold plug problem even better. So I have videos about cold plug, and we talked about the cold plug problem in depth in that video that we put out a couple of days ago, stuff like that. So there's also an item that's been added in to help with preheating the vertical exhaust, which is part of fighting the cold plug. So to fight the cold plug, there's basically two big steps that you add in. One is to preheat the vertical exhaust, and two is to triple prime the riser. And if you do those two things, you're pretty much set and ready to go to be able to run the rocket mass heater. Because if the temperature outside is the same as temperature inside, which it generally is for a cabin, then it's going to be very difficult to start. This is the Achilles heel of a rocket mass heater. So those are the two big things that were added in here. A lot of cob and a lot this improved port for priming the vertical exhaust. Anybody got anything to say about the rocket mass heater upgrade in the red cabin?
On the port, the priming port, I was there last weekend and I looked at it, and it's a really cool design to have something. You have your cap, and then there's a metal piece that comes out of the end.
I see your hands moving, but I don't hear any sound. But all right, to finish what you said, there's when you pull the cap off, there's a little weird metal thing kind of sticking out of it on the inside. And the idea is that you wad your paper up around that metal thing, and then you set it on fire, and you put it back in there. And while it's burning, you start priming the riser. So that wad of paper combined with that knob. In fact, I think it would be kind of cool to come up with some fire starters that might burn for longer than a minute, because a wad of paper is going to burn for a minute. But it would be great if we had something like with sawdust and wax, perhaps, that could be stuck on that. And then that might burn for 10 minutes. And that'll really get the vertical exhaust warmed up. Yeah, it is an interesting thing that Mud has come up with to prime that vertical exhaust. So this thing is not a problem for anybody building a rocket mass heater in a house. The The only time it's ever been a problem in a house is if it's a summer day and somebody's decided to show off their rocket mass heater to friends. Let me show you how easy it is to light. And then, of course, it's going to be horrible because the whole cold plug problem. All right. Next item on the list is the rocket oven. I don't think there was a lot of progress. There was some sort of weird metal frame that was created, which I hate. And I wish there was no metal frame. It's supposed to be a cob thing. Oh boy, do we have video or pictures of that? Oh, so my understanding is that part of what we're going to do is we're going to actually use the box from an abandoned electric oven, which is going to include the door. Oh, that must be the J-tube that's going to go in for the new rocket oven. That's a pretty standard looking J-tube right there. So that's not bad. But I know that they want to use like a regular electric oven door and box. So on the interior, it'll look like a regular electric oven. But there's some sort of weird metal frame that they came up with that I thought was really bizarre. That's Jim sealing up the, he's brazing the electric oven in order to be able to like seal up any little holes and stuff. So that way it'll be a white oven and not a black oven. Oh, and there's a view of it. See, look at that big gaping hole in the back that's going to need to be plugged. So, but I thought that was a pretty cool idea though, to be able to reuse an old electric oven in that way. That's not bad. Just got to cork it all over so that way it'll carry the heat in, but it won't overheat, and it also will keep all the gases out, the exhaust gases out. All right. Did anybody work on that oven, the rocket oven project? Okay. Another project that Mud worked on was the rocket hot tub. I kind of feel like we got to a conclusion where the kiddie pool was heated up to hot tub temperatures in 90 minutes. And I felt like that was kind of long, but then the hot tub is about 3.5 times bigger, which means that getting the hot tub water heated up that fast would be something like what, 4.5 hours or something? That just seems crazy long. And so, however, okay, the kiddie pool was 90 minutes, but the kiddie pool was just sitting on the ground. I think that if the kiddie pool were embedded into the sand, maybe 30% of that time would have been eliminated, because the kiddie pool is going to give off heat really fast while it's being filled up with hot water. But then the sand would be very insulative and hold that heat in. And so, there we've got a picture of the experimental water heater for the hot tub. And there's the kiddie pool getting heat, getting a bunch of hot water put in as an experiment. And so, yeah, if it was embedded in the ground, I think it would have been only an hour that it would have taken for us to get it up to hot tub temperatures, as opposed to an hour and a half. So that would mean that if we tried to fill up the whole, the full-sized hot tub, it may have only been 3 hours, although that would have even cooled some more as we're trying to heat it up. So it might have been even longer than 3 hours. So I think that this needs further experimentation, and Mud and I have a lot of ideas about further experiments that can be done to be able to, it would be great to get the hot tub going from empty to full and ready for people in under an hour. And we have a few ideas about how to pull that off. Anybody got anything to add about the rocket hot tub? Next up on the list is the Bob line and the Bob Ra line. And so those are big cables that are going over the classroom. So we now have 3 cables going over the classroom so we can attach tarps to them, sunshades to them to help cool the building and cool the surrounding area. I'd say that by the end of the PTJ, we got a fair number of the sunshades deployed, but I think that we really wanted there to be more. And so I kind of feel like the other thing is that where we had sunshades, and so there you can kind of see that's the current Bob line going out, and there you can see some of the sunshades in place, some of the first sunshades in place. I kind of feel like in order for this to work, I think that we went with sunshades that were too big. And so because they were too big, they tended to kind of sag. And then if they touched the top of the building, then they would lose all their effectiveness, or not all of it, but a lot of their effectiveness. So there's the Bob line where it ends in that pole inside of Arrakis. All right. I think that the Bob and Barbara system has huge potential to cool the space so much more than it did this last year, and there's just more experimenting and more work to be done. Has anybody got any feedback on the Bob system?
I think that you have to keep them in tension. I don't think that the size matters as much as just that they're just on those wires, and when they're on the wires, they can pull together, so they'll just rest on the top of the roof, and then they won't be shading the roof at all. They'll just be resting on them, especially when it's raining. They just kind of flapped around on top of the roof. So if you attach, ropes or wires or whatever to each of the sun sails so that you can keep those spread out. The other thing is that I'd put the wires higher than they are today, because they're just, maybe 3 or 4 feet above the roof. And I think that they need to be higher than that to get enough airflow between the roof and the sails. That would be my feedback on those.
I think that the wires are currently 8 feet higher. And I think that because the sunshades were put on in such a way that they attached directly to the wires, that they then would sag between the wires. Whereas if we went with a smaller sunshade that was maybe 4 feet short, then they could be attached in such a way whereas there would be less sag. Like there could even be a bungee cord holding it or something like that. And we wouldn't have complete coverage, but that's okay. The other thing is that if the sunshades sag over the areas where people are working outside, that doesn't matter, because the sunshade is about 20 feet up in the air. If it sags a lot, no one cares. So I think the thing is about the parts that are over the building. And while I do think it helped keep that building a lot cooler, I think that the building would be cooler, as contrary as this sounds, the building would be cooler still if the sunshades were smaller. And then they could actually be quite a bit above the building, instead of like you mentioned, some of the sunshades ended up touching the roof of the building, and it's like that's losing most of your shade power. So does that sound about right? Katie?
I think that we're misunderstanding each other a little bit. I mean, the way that I saw them sag wasn't between the two wires. It was, on the same wire. So the sunshades were basically folding upon themselves. And so if you'd keep them, let's say directions. So the wires run north-south, right?
Ooh, I think I
so
do understand.
north and south, and they're folding like this, like a burrito or whatever. And so even with the smaller sunshade, yeah, I think that they could still fold together. But if you had tensions keeping them as far north and as far south as possible, then they wouldn't fold at all. And you can try it with the smaller shades. I think that as long as you have them able to fold in on themselves, then they're not going to function as a shade. But I think that we might be misunderstanding each other. So
what? So no, I agree with you. Are talking about a completely different thing, and now I understand what thing you're talking about.
Yeah.
And I agree with your analysis. And so late in the skip event, we got some new parts in where we were able to add that level of tension onto the sunshades, which are kind of chained it together to kind of keep them from bunching up.
Yep.
Yeah, and keep them pulled out.
Yeah, that's mainly what they need.
Right. I agree.
Yeah. Okay, cool.
Yeah, and now they have that, and some of them are still touching the roof, and I think that's because they're too big.
Okay.
But I think that the bob system is working quite well, but it has room for further optimization. Okay. Next up, the heat protocol. Slushies. You guys like the slushies all right?
Yeah, I like the slushies. Yeah, no, it was nice. For those who don't know, when it gets above 95, every hour, the slushy folks come around and they're delivering delightful slushies, which are basically shave ice with some sort of flavoring. Could be juice, could be some sort of stevia flavors, and those were good. I have to say that I chose to work on the lab at least one or two of those days and missed out on the slushies. So that was kind of one of those, you pick where you want to be, and do you want slushies or do you want to work on JR's root cellar? It's kind of a hard choice sometimes, but no, it was fun. It was fun working up there, and it was fun getting those slushies too.
Speaking of the lab on a hot day, something which we got to make a video of, and we got to make it right away, is that somebody got video where, if I remember correctly, it was 100 degrees outside, and they videoed a thermometer outside, and then they moved the camera to a thermometer that was inside, and the indoor temperature, I believe, was 70. And so, I think that they did something similar up at Cooper Cabin, but they got a temperature of 110 at Cooper Cabin. But the problem was that thermometer was in the sun. So it's that's not exactly a fair test. Because you put it in the sun and it'll peg out. Yeah, there's the indoor temperature at Allerton Abbey, 68.
Mm-hmm.
While it's 100 degrees outside. And so is this the video? It's it's 100 outside and it's 68 inside. So we did have a few days that were over 100. It hasn't gotten that hot since the summer events. But it wasn't. It seems like 2 years ago was hotter. Last year wasn't too bad, and this year was pretty hot. But we do have 24 things that we roll out for the summer events. when the temperature hits 95 or higher. There's Des misting himself off. Looks like up at the lab, at a lab project. So, but that's going to be a whole other podcast for another day to talk about all the things we do for heat mitigation. But it does seem like when the slushies go out, in fact, we've had a couple of people where we like in the morning, we talk about the forecast today is for a high of 85. And then people would complain that would mean that there'd be no slushies. And
I think 94 would be the worst. You get all of the same suffering as 95, but you don't get the slushies. That's really crushing.
Yeah, there's some slushy addiction problems too. So, but go ahead.
One of the tough things this year up at the lab was that there was, I don't know if there were air pockets in the water or what it was, but we couldn't use the shower up by the sauna. And last year, that's how we kept cool up there, since the heat protocol is only for base camp, mainly.
Well, we found the problem,
and
if you grabbed hold of the hydrant and you turned it, it was completely unattached to everything else. And when the water would come down through the plumbing, it would just drain out underground at the base of the hydrant there. So I would say that got there was about 2 weeks where the boots were going in there off and on to dig a hole all around that and get it out. And it got finished, I think, 2 weeks ago. Was it finished while you were here, Clay?
It had been finished right before I got there. So yeah,
okay.
2 weeks sounds about right.
Was that the hydrant by the sauna or up
Correct.
at the
Yeah. The hydrant right next to the sauna was rather ill.
Yeah, it was tough. It was really tough being up there in 113 degrees working on the willow feeders and not having any way to cool down.
If you had 113, that's a record high for the county.
That was what the thermometer said at Allerton Abbey one day.
Was it in the was the thermometer in the sun?
No, it was in the shade.
Wow. Okay, that's because the highest temperature I've ever seen recorded here in the shade is 107.
Yeah. Well, I might be mistaken. That's what I seem to recall, but it could have been 107.
Okay.
All that Fahrenheit stuff.
All right. Let's move on. The next item I have on my list is Yoga Yurt Cob Floor. And that was Michael Otten leading that build. We put a video out not too terribly long ago. Jeff, you spent some time on that project, didn't you? I can't hear you. Are you muted? Yeah, you are muted. So to just simply talk about the project, since Jeff's microphone is muted. Oh, try it now, Jeff.
I just got a bad connection.
Oh, okay.
Slow connection.
All right. In that case, I'll try to talk about it. And that is that we got the idea of putting in this yurt in this spot. I thought the thing to do was to do what everybody does with a yurt, and that is to put in a wood platform. And Michael Otten and another guy that was here 2 years ago, said, we want to do this idea of a cob floor and an earthen integrated floor for the whole project. And it'll do a wonderful thing about more heat in the winter, and it'll be cooler in the summer. And everything that they said to me, I said, it sounds like about 20 times more work than putting in the standard wood deck kind of thing. And they said, no, it'll be a little more work, but not that much. And I think it's turned out to be a lot more, like more work than they thought, but maybe not as much work as I thought. But I do got to say, the floor is very, very handsome. It is a beautiful floor. Uh, and and on top of that, um, Michael Otten is an expert with cob, and he has this design of a thin cob floor, which is amazing to me because usually when you make a cob floor, it's a good 8 inches thick. And he's like, no, no, we're going to do something that's just an inch thick. And it seems to be working. It's, I mean, and he talks at great length about how he pulls it off, but that's a lot less work to be able to make a cob floor with only an inch of cob, because that's the one thing about cob is always a giant time suck. So anyway, he started on it last year. He got a late start, and then this year it got finished, and it looks just dreamy. I'm really looking forward to. Well, I don't know if anybody's gone in there to do any yoga just yet. So hopefully soon people will start yoga-ing in there. But does anybody have any feedback about the yoga yurt cob floor? All right.
I second that it is really attractive. I was in there and it's good to look at. You know, you walk around in there and I couldn't even walk with shoes on such a pretty thing. You know, I had to be in my socks and walk around and like, oh, this is really nice. And yeah, it's not like, I don't know, it's different than a lot of floors that I've been on in the sense that it's not, it doesn't bounce at all, but it's also kind of forgiving. I don't know how to describe it other than I like walking on it for sure.
Okay. One of the things that was done for textiles was rug repair. And it seems like we've done that every year for the last several years. I'm so grateful that it happens because we get these little rugs and they get all worn out and beat up. And I think it's the permaculture way to repair them and keep them in operation. For other textiles projects, this year there was window quilts was a big one, and there was already some window quilts that had been built. And but there were some new window quilts that were made for the library. And there's Oprah. That looks like she's doing some rug repair there. But has anybody got anything to say about rug repair or window quilts? So the next thing on my list is willow feeders. And so, Katie, what do you got to say about willow feeders?
Oh, so much. So a few days or a week before I came out this year, I found out that I was going to try to do some repairs to the willow feeders, the 4 that exist. And there are some drawbacks or interesting choices that have been made for each of the willow feeders. And we tried to just make sure that everybody who participated got to know why we were making the repairs that we were making and how they could build a willow feeder that prevented them from having such, well, like some of the interesting choices that were made previously. Part of it was that we moved one of them into the sun so that the trompe wall would work better, but there's still a lot of repairs that need to be done. Yeah, we looked at the skiddable structures, what works and what doesn't work. Basically, if you're going to build a trompe wall on a willow feeder, which I personally am not a huge fan of, but Paul is, and I'll let you know why I am not a huge fan of it. I would not put a willow feeder in full sun. I think that it's much better that they can stand shaded, or else if you're going to have them in full sun, just make sure that they're fully insulated so that the willow candy doesn't smell so bad. Then, of course, you build the trompe walls or solar fans in order to get rid of, look, there's me. in order to get rid of some of that smell from the candy box. So you want the trom wall or the sun, the solar fan to be in the sun, of course. But then, of course, I don't want the willow feeder in the sun. The trom wall needs to have the sun. If you are going to build a willow feeder with a trom wall on it, please make sure that the trom wall is directly above the skids on the front or the back, and not on the side, because they weigh lots and lots and lots. So they're going to, if they don't have anything supporting them beneath, if they're just hanging off the wall, then the entire building will start leaning. And with this one, this is Willow Wonka down at base camp. And as I understand it, when you guys skidded it down from the lab to the base camp, the trom wall was on the downhill side, so the whole building kind of almost fell over, except the door opened and stopped it from falling over completely. Also, the bracing, the diagonal bracing, was going the opposite direction than it needed to go in order to keep that trom wall up. So since it was more of a, I don't know, rhomboid structure, when we got to it, we used these ratchet straps to try to square it up a bit and put some bracing in going diagonally the other direction to try to alleviate a little bit of that weight from the trom wall. So we also tried to fix some of the doors to the candy boxes so that they'd be easier to open, so they wouldn't be quite such a tight squeeze when you're pulling the cans in and out. And tried to make them a little more fly-proof, but when you're working with the dimensional, I mean non-dimensional lumber, just like the stuff that's there, it's really, really tough to make it fly-proof. So then we started a little side project because everybody loves Stephen. So we decided to build Stephen, well, at least start building Stephen a willow feeder, because also we recognize that the part of the lab where he is setting up his acre needs a willow feeder, because there's one in Cooper Cabin and one by Allerton Abbey, but that is far, far away from where many people are. So we decided to put it about where, I mean, we asked him very slyly what he liked about the 4 willow feeders that already exist, what parts were his favorite parts of those, what he thought worked well, what he thought didn't work well. If he were to have a willow feeder on his property, where he would like to have it and why. And then we tried to implement all of those different wishes and wants to the frame that we ultimately purchased and built for him. And we had an awful lot of fun. Mike and Rio did a phenomenal job leading a great team, and we just had so much fun. We were up at the meeting spot at the Third Space Sauna, having a wonderful, wonderful time Thursday night and Friday night. Wednesday night, I don't know. We were there a lot because we hit all of the all of the material that we spent the week previous buying in different places around Montana. And then we hid it all behind the sauna, because Stephen doesn't like to sauna, so it's pretty safe from him there, except, of course, on Friday, when he decided that he was going to be a diligent person, a diligent dad, and make sure that everybody's projects were going really, really well. So we had this tremendous Shakespearean comedy almost, where we were trying to keep him away from the sauna. And everybody's got their own stories about what they did to try to keep Stephen from the sauna, but Clay finally saved the day and just made him swear a blood oath not to come over to the sauna. So we had the great reveal. It was a little bit Stephen King creepy-ish, with people walking out of the forest singing to him as the dust settled around the cars that took him over there. And then we revealed this beautiful structure, which at least is most of the framing for his poo with a view.
Excellent. It is.
Yep.
It is amazing and glorious, and Stephen is super duper happy, and it's been a wonderful thing.
Good.
That's the whole list. We talked about the whole PTJ. All right. Anybody else want to add anything about the PTJ for 2024? Nope. I mean, we got right now, we do have some people coming out for the theme weeks. We're trying to get the theme weeks going. And so people who want to experience some of these things can come on out and and be part of it. But I think I think, oh, I want to come back so I can see his cabin. All right. So, all right. If you like this sort of thing, come on out to the forums at permies.com, where we talk about events like this, homesteading, and permaculture all the time.
Time.